This is Lieutenant Chu, and in this video I'm going to give you a brief demonstration about the use of a DTIMap, an Osirix plugin for creating FA map and diffusivity map from DTI images. So here we have a demo dataset, and the first thing you want to do is you want to open the images in 4D viewer. Don't open it in 2D viewer, because if you do that, the plugin will not work. So the image is loading. We can go through different slices, make sure all the images are correct, and then you just go to plugin, image filters, and DTIMap. The main interface of the plugin will pop up, and here in this table you'll see the diffusion gradient tables. In this column, the B values, and all these the following fields are gradient vector fields. And in this case, this gradient table has been saved in DTIMap fields. If the images are acquired from older scanners, this information might not be available, and you need to use another function of the plugin. That is, you can load the gradient table from. Basically, you will load the images. This file contains multiple rows, one row for each gradient direction, and the first field is the B values, and the following three fields are the gradient vectors. And so you can also, after you load the gradient table, you can save the gradient table to the database of the plugin. So I'm just going to give it a random name. Let's say Siemens 64. You can see the gradient table has been saved here. Here are the previous gradient tables that I've saved. I can switch to another table. It will let you know if the number of directions that does not match. So, and now you also have the option to reload the DTIMap fields. So, and here is in this box you can type in a threshold, and this threshold tells if the voxel values are below this threshold, the DTI parameters will not be calculated. What I do usually is I just move my mouse over here and see the relative values of the background and also the tissue. And keep in mind this threshold only applies to B0 image. I'm going to go back to B0. So you can see in the white matter the value is roughly 300. So I'm going to, in the background, it's pretty low. It's about like 10, 20. So in this case, I'm just going to set the threshold to be 50. And also down here you can see some check boxes. These check boxes determines which maps you want to generate. The B0 is just the estimated T2 map, MD for mean diffusivity, FA for fractional anisotropy, and color FA. D1 is the axial diffusivity, which is also the largest eigendiffusivity, and D2 is the second eigendiffusivity, D3 third eigendiffusivity, and red is the mean of the D2 and D3. You can turn them on and off. So in this case, I'm going to turn these three maps on. And here you can see the autosave box. If you turn this on, the generated image will be saved automatically to the database. In the case, in this demo, I'm not going to do that. And after all this have been set, you can click this button and the maps will be calculated automatically. And from these, you can read from the caption, these are the fractional anisotropy map of the FA map. The value, remember the values has been scaled to 10 raised to the power of -4. And so if I say if I put a region of interest here, you can see the values reads 4370. So what it means is that the FA value is the mean FA value here is 0.437. Okay, if I go back to the database, you see because I didn't check the autosave box, the images are not saved to the database. But if you change your mind, you can use my other plugin, the exporter, to save the images back to the database. In this case, I'm going to set FA. If you want to set the saved images to have particular series ID, you can set it here, or you can leave it blank for the software to determine. Now you just click export database. Okay, the images will be saved back to the Osirix database. You can see it's here. Let me reopen it. Okay, see, again you can use the RY tools from the Osirix to do different kinds of measurements, or you can use the exporter to save the images. That's it for DTIMap.